Hi, I'm Arturo Cesar Montaño. Here's my student ID, and I will be solving the following circuit for the class of circuit analysis. To begin with, let's define some concepts. The first one is the mesh. The mesh is this enclosed loop we're having, that in this circuit we're having 4 meshes, which each of the meshes will have its own current. The second very important term is the Kirchhoff voltage law, that states that the sum of the voltages inside each inside a mesh will be equal to 0. This is essential for circuit analysis for later on. Now in this case, we have to get what is the current, what is the voltage that is passing through this resistance, and we're going to call it Vx, and the power that is given, in this case, the current source. In this case, it's very important to notice that we cannot apply the Kirchhoff voltage law directly in the current source. This means that the voltage is unknown, so therefore we have to calculate first the voltage that is going through this resistance, through the resistance of 41 ohms, and due that they are in a parallel configuration, the voltage here will be the same one for both cases. So in this case, let's define some laws, very important. The first one is the Ohm law, which that states that voltage is equals to the to current times the resistance, and that the power equals voltage times the current. In this case, using the Ohm's law, we can get how to get Vx. In this case would be 45. The difference, it would be current 1 minus current 2. And in this case, first we have to get the current here. So we have to get first the voltage source, in this case 41, times the current times current 4, and with this we can get what will be the power source of the current source, which in this case would be the voltage source times, in this case will be minus 1/4. In this case it is minus due that in here we're dealing with an active component, which means that this component is delivering power. Now with all of this said, to do the analysis, we will join these two meshes in order to form something that it is called as a super mesh. This super mesh allows us to mix these two meshes that are related with the same current source. With this, what I'm going to do now, I'm going to define and do the Kirchhoff voltage law to the super mesh, the inside and the outside, and to both of each meshes. And once I do all of this, I'm going to end up with a system of equations. With this system of equations, I'm going to solve them in order to get what are the currents of all of this. So I'm going to Right now, I have already calculated. I just stated all of the equations, and I'm using the calculator. I solved the system of equations. In here, it is very important to notice that in here, and that in terms that due to the polarity that we're giving here, in this case, the outside of the super mesh will be positive due to the minus plus, which in this case, due that we're taking clockwise current. This one will given that all of the outside will be positive. In the case of the inside, if we consider the direction of the current source, it is going upward. So in this case, it is telling us that the current 4 minus current 2 will be equals to 1/4 ampere. I already calculated all of the currents, and thanks to this, now I am able to calculate Vx and the power source, which I'm going to just substitute the corresponding values in order to solve it. After making all of these calculations, we obtain that the voltage of Vx is 5.9, and in the case of for the power source, first we obtain, as I was mentioned previously, the voltage that is passing through this resistance, and once we obtain it, which in this case is 3.6, we are able to finally obtain what is the power source. In this case, what is the power being delivered by the power source? In this case, is negative due that it is an active component, and is 0.9 watts. Thanks.